So, in this video, I'm going to talk about synthetic division. Synthetic division is a way to divide certain polynomials. We'll talk about the restrictions in a little bit, but it's a way to make it a little easier. It's similar to pretty much doing the same work as long division, polynomial long division. It just goes by a little quicker. So we're going to start with this problem: x to the third plus 3x squared minus 6x minus 8 divided by x minus 2. Now when we did this with long division, we'd write this out: x to the third, 3x squared, 6x minus 8, divide by x minus 2. And then we'd come along, and we're always doing first term and first term. So x into x cubed gives me x squared. X squared times x minus 2 is x cubed minus 2x squared. We subtract, so 3x squared minus a negative 2x squared is 5x squared. These, of course, cancel. We bring down the next term, and then we just keep going again. First term by first term. So 5x squared by x is 5x. So 5x times x is x, 5x squared. 5x times a negative 2 is a negative 10x. Again, we subtract this. So negative 6x minus a negative 10x is 4x. Bring down the negative 8. And then we say 4x divided by x is 4. And we go 4 times x minus 2 times 4. We subtract that, and again, negative 8 minus a negative 8 is 0. That's my remainder. This is my answer, and since the remainder is 0, we could also say x minus 2 is a factor, which is one of the big reasons we do polynomial division, is we're trying to check and see if something's a factor. Synthetic division works really well to do this. With synthetic division, we pretty much are going to boil all of this work into a short little package. And we're going to do that by not worrying about the x's. Now, it's kind of like when we're doing division with numbers, we worry about place values, the ones, the tens, the hundreds, the thousands. We keep track of place values. Well, we're going to do the same type of thing. The position it is in, the first term is always the highest degree. Next one is next down, next down. If we keep them in that order, we don't need the x's. We can deal with just the numbers. So we pull off the coefficients: 1, 3, negative 6, negative 8. Okay? We're dividing by x minus 2. One thing with synthetic division, this must always be 1x. We can't do this process of synthetic division if there's a number in front of the x, or this is not a linear term. But if we have that, we're good. Now you notice here I'm always subtracting. I don't want to subtract, I'm going to add. I'm going to do the opposite. So since this says subtract 2, I'm going to use the opposite, and I'm going to go 3. I don't know what I'm doing. This is doing weird things. There we go. I'm going to do plus 2. Now, your book and a lot of books I see put that plus 2 up here. I like it down here. It makes more sense to me when I'm doing this. Okay, so what I'm going to do is first pull down the first number. Now this 2, this number down here, I'm going to multiply by this. So 2 times 1 is 2. I put it up there. When I come down, I add. Because when I'm coming down, I'm always adding here. Well, I'm subtracting, but I'm subtracting a negative makes it add. So 3 plus 2 is 5. Times 2 is 10. 10 minus 6 is 4. Times 2 is 8. Negative 8 plus 8 is 0. Now, if you look at what we have, 154. 154. That's the answer. 0. That's the remainder. If you look at these numbers as we went through, we took, here we had 2, 10, and 8. Now in here it's a -2, -10, -8. Here's +2, +10, +8. But that's because we were subtracting. You subtract, you could say add the opposite, so that makes that a +2, makes that a +10, makes that a +8. So these are those same numbers here. The numbers we got here, 5 and 4, we come down with this. We're getting all of these same numbers, we just don't have the x's involved. This was originally, the original problem, this was an x cubed, this was x squared, this was x, and this was my constant. They were in order from the highest degree. We took a third degree divided by a second degree, we get, or by a first degree, we get a second degree. So this is my x squared, that's my x, that's my constant. So my answer is x squared plus 5x plus 4. Same thing as we got, pardon me, same thing as we got here. Now if I wanted to divide it by something else, say instead of x minus 2, I wanted to divide by x plus 3. I'd set up the problem the same way. 1, 3, -6, -8. Since I got a plus 3 here, I put a minus 3. I do the opposite. And then I come down. I bring down the 1 times a -3 is -3. Add it is 0 times a -3 is 0 plus a -6 is -6 times -3 is 18 minus 8 is 10. So my answer to this problem would be x squared. I have a 0x minus 6 plus my remainder of 10 over x plus 3. That's the idea with synthetic division. We can see if we get a remainder of 0, if we don't get a remainder of 0. We're just working with those numbers. So let's try another example. Let's go with x to the 4th plus 4x to the 3rd minus 3x squared minus 14x minus 8. And let's divide it by something. So let's try x plus 4. So we'll do 1, 4, -3, -14, -8. And we'll make this a minus 4 here. Because again, we're taking the opposite of this, because instead of subtracting, we're going to do adding. Now pause the video, try this out yourself, come back and see if you get the same answer I'm going to get. Okay, let's do this. So again, when we're going to add when we go down, and we're going to multiply when we go back up. So 1 comes down times a -4 is a -4, plus 4 is 0, times a -4 is 0, plus a -3 is a -3, times a -4 is going to be 12, plus 14 is a -2, times a -4 is 8, plus a -8 is 0. So my answer is x, this was x to the 4th, so I'm going to say x to the 3rd. I have 0x squared, so I'll go to the minus 3x minus 2, and there's no remainder. So this is indeed a factor. Now you go ahead and try to do this again. This time, divide by x plus 1. Pause the video, give it a try. Okay, so we bring down our coefficients. 1, 4, negative 3, negative 14, negative 8. We said plus 1, so I'll put a minus 1 here. So let's go ahead. 1, negative 1, 3, negative 3, negative 6, 6, negative 8, 8, 0. Again, this was a factor. My answer is x to the third plus 3x squared minus 6x minus 8. Now, the things that are important. Again, when we do this, let's go to a new page. For synthetic division, we need terms, and actually, let me restate that. We need all of the terms. In descending order. Even if one is missing, we got to plug in a 0. We need placeholders. Because as we said, like with doing numbers, where we worried about the ones place, the tens place, the hundreds place, the thousands place, if you don't have a number in there, you have to put a 0 as a placeholder so you know what those numbers mean. We got to do the same thing with our terms, with our third degree, our second degree, our first degree. So we need all the terms, and they have to be in descending order. We can only divide by x plus or minus a. We can't deal with anything higher than a first degree with synthetic division. We can't deal with a leading coefficient, a number in front of the x. It's an x plus or minus some number. If we have that, we can do the division. If not, we go back to polynomial long division, or we can use the area model to divide if you're comfortable doing with that one. The synthetic division works great for if you are dividing by x plus or minus an a. But keep in mind, when we're trying to factor, we're looking for factors of x minus a root. So they're all in the form of x minus a number, or x plus a number if it's a negative root. So it works great for checking if it's a factor. Otherwise, that's kind of where this is useful for. I want to do another example here with having all the terms in descending order. I'm going to take and do this problem. If I were to do x cubed minus 64 and divided by x minus 4. This does not have all the terms. So I'm going to have to rewrite this as x to the third plus 0x squared plus 0x minus 64 divided by x minus 4. I have to have if it's a third degree polynomial, I have to have a third degree, a second degree, a first degree, and a constant term. So then I can come and I can go 1, 0, 0, minus 64. And I can go, this is x minus 4, so I'll go plus 4, and we'll come down 1, 4, 4, 16, 16, 64, 0. So this answer is going to be x squared plus 4x plus 16. But I got to get those extra zeros in there. I'm just going to put a couple more problems on here for you to try. You can pause the video, then I will come through and work them for you so you can quick double check and make sure you're doing that right. So let's try 2 more problems. 2x cubed minus 7x squared minus 24x plus 45. And we're going to divide this by x minus 5. Then I want you to try x to the 4th plus 2x cubed minus 11x squared minus 40 and divide this by x plus 4. Pause the video, try to do these 2 problems, then bring it back up and I will have them completed for you. This one I will go 2, negative 7, negative 24, 45. I'll put 5 here, since that's minus 5. So I get 2 times 5 is 10, minus 7 is 3, times 5 is 15, minus 24 is a negative 9, times 5 is a negative 45, is 0. No remainder, so my answer is 2x squared plus 3x minus 9. If you need to pause this to revisit the second one, do that now. Let's work that. I got 1x to the 4th, 2x cubed, negative 11x squared. I don't have an x term, so I put in a 0 and a minus 40. I'm dividing by x plus 4, so I'll go a minus 4 here. So I'll bring down the 1 times the negative 4 plus 2 times the negative 4 minus 11 times the negative 4 plus 0 times the negative 4 is negative 88. So this one does have a remainder. So it was x to the 4th. So my answer is going to be x to the 3rd minus 2x squared minus 3x plus 12. And then we have my negative 88 over x plus 4. A lot quicker than long division.